Hi everyone, good evening, and we are back into our session. So we are discussing single variable calculus, in which we are talking about indeterminate forms. And in the last session, I have covered L'Hopital rule, okay, to determine the limit of a function at that you have to understand. Okay, so whenever we have got 0 by 0 form or infinity by infinity form, we can apply the L'Hopital rule. Okay, and also we have seen the failure of L'Hopital rule. So this lecture is going to be L16, and we will cover other forms of indeterminate forms, and also we are going to use just L'Hopital only, right? So that's what you have to keep in mind, right? And then after this session we will start application of derivative, which is very important for your gate examination. Okay, limit is also one question you can expect, continuity one question you can expect. Okay, chaliye. So this is lecture number 16, and we are going to talk about uh, you know uh, indeterminate forms, like you can say 1 to the power infinity, okay, 0 to the power infinity, and okay, I believe this is fine. 1 to the power infinity, 0 to the power infinity, and there are other forms as well, right? So 1 to the power infinity, 0 to the power infinity. Let me tell you all the forms, right? Yeah. So 0 to the power infinity, 0 to the power infinity is not the indeterminate forms, right? Okay, please remember that. So let me write here what are those. So 0 by 0, infinity by infinity, these are one form of the indeterminate forms, and infinity minus infinity, okay, this is again one form of the indeterminate forms, and 0 to the power 0, infinity to the power 0, and 1 to the power infinity. These are the indeterminate forms. So this is first, this is second, and this is third. So we are going to talk about this part first, okay? Then we will come to this, okay? So, so first of all, we will deal with infinity to the power 0, or you can say 1 to the power infinity, or 0 to the power infinity. Same concept is going to be useful, okay? And we are going to use L'Hopital only, okay? I will show you how, okay? So what is the first step that you have to understand? Suppose we have got indeterminate form, right? Indeterminate form, right? Form of the type 0 times infinity, right? 0 times infinity, okay? I think I haven't written 0 times infinity. Yes, I must write here 0 times infinity, right? So this is also one form of the one indeterminate form of the type, right? So 0 times infinity, right? So suppose what I'm trying to say here is that 0 times infinity, right? So statement क्या रहेगा? Suppose you can say, suppose f of x is going to 0, okay, and g of x is going to infinity, okay, as x tending to a, right? As x tending to a, your one function is becoming 0, one function is becoming infinity, right? So 0 into infinite, okay? So this is nothing but an indeterminate form, okay? Indeterminate form, okay? Because you have got fx into gx, right? Fx into gx. So so you have got fx into gx, okay? So your fx is becoming 0 as x tending to 0, and gx is becoming infinity. So what you can do here is you can write this fx into gx as, so you can write this fx into gx as, okay? So what you can do, you can take fx here and write 1 by gx like this. Like you can take gx and take into the denominator, so it will be nothing but 1 by gx. So fx is 0, and 1 by infinity is also 0, right? So this is nothing but L'Hopital. Like this is nothing but 0 by 0 form, and you can apply L'Hopital, right? Now you can apply L'Hopital, or you can write this as fx into gx can be written as, you keep gx as it is, and you can write 1 by fx. So this is nothing but infinity by infinity form, okay? infinity by infinity form. Understand? Infinity by infinity form, 0 by 0 form. See, if 0 by 0 form is there, so what we are doing here is, suppose you have to compute the limit of two functions which are given in product, right? Okay. Suppose you have to find limit x tending to a fx times gx, right? So how to solve this? If your f of x is becoming 0 and g of x is becoming infinity, right? So you can write in this format, okay, fx upon 1 by gx, fx upon 1 by gx, and gx upon 1 by fx, right? So this is nothing but what, 1 by fx is infinite only because if fx is 0, ठीक है? तो आपको ये ध्यान देना है कि जब भी प्रोडक्ट में दो फंक्शंस रहेंगे, whenever product is given, right, and limit extending to a is there, right, and your fx is becoming 0, so आपको इस फॉर्मेट में कन्वर्ट करना है, right? You have to convert your 0 into infinity. Okay, what you're doing here is you're converting 0 into infinity to 0 by 0 or infinity by infinity form, right? So that you can use now you can use what, L'Hopital, right? You can use L'Hopital. So let me take one question and explain you. Let me take one question and explain you. Okay, so the very first question I'm taking here is, suppose you have been given you have to compute limit x tending to infinity, okay, x sine 2 by x, x sine 2 by x, right? Now how to solve this question, right? That is a very important concept. So you see here, x tending to infinity means there are two functions, okay? One function is x and one function is nothing but sine 2x, okay? So what you can do here is, x tending to infinity means x is becoming what, x is as x tending to infinity, so it is a form infinity times 0 form, right? Okay, because 2 by infinity is 0, sine 0 is 0, right? So 0 into infinity form, right? Now you have to convert this into infinity by infinity form or 0 by 0 form you can write, okay? So what you can write this as limit. Okay, so what we can do here is 0 by 0 form we can do, right? So sine 2 by x you can keep up and x you can take down to 1 by x, right? So now it is nothing but a 0 by 0 form. 0 by 0 form. Now we can apply L'Hop. By L'Hop, what is L'Hop, guys? You have to differentiate numerator. You have to differentiate numerator. So you can differentiate now. Sine 2 by x ka differentiation what? Cos 2 by x. Now you have to also differentiate 2 by x, which is nothing but, you know, minus 2 by x square. Minus 2 by x square, right? Okay. If you differentiate 1 by x means 1 by you must know, okay, already I have covered. And what is differentiation of 1 by x? That is nothing but minus 1 by x square, right? Now if you plug here you know, if you see here, if you plug 0, right, so this x square and x square gets cancelled, right? ये cancel हो जाता है, and this minus sign also gets cancelled. And if you put infinity here, so this is nothing but cos 0. Cos 0 is 1, so answer will be 2. So how simple this question is, okay? If you know how to convert product form of indeterminate to 0 by 0 or infinity by infinity. So I hope this makes sense, right? So 0 by 0 or infinity by infinity is one of the very easy thing. So whenever you will get to see product, two functions are given which are in product, right? fx and gx, and you have to find the limit x tending to infinity. So आपको करना क्या है? You have to convert infinity times 0 as 0 by 0, okay, and you will get the answer like this. So I think this is clear. Okay. So this is the first question that we have done. It is so simple, right? So see, L'Hopital rule can only be applied to 0 by 0 or infinity by infinity. Understood? But what we have to do? So you have to convert, you have to write, these are the particular cases, right? So we can change, okay, between, you can say f by g, or suppose we have been given like this also. 0 by 0 form or infinity by infinity form. So f by g. So f can be written as what? You can also write f as, like, you can write 1 by g upon 1 by f. So you can write like this also. No problem is there. Okay. Now we will solve one more question. Example number 2. Okay. So example number 2 is nothing but, okay, example number 2. Consider a limit x tending to 0 plus, okay, x to the power n ln x, right? X to the power n ln x, right? Where n is nothing but the natural number. Natural number, okay. Now we have to solve this limit, okay. Now you might notice here is that again 0 plus is nothing but minus infinity, okay, x equal to 0. So first is 0 and then 0 into minus infinity. So this is also nothing but 0 into minus infinity, okay, form. So what we can do here is we can write this as, okay, we can write this as infinity by infinity form, okay. So what we will do, limit x tending to 0 plus, you keep ln x up, that is infinity only at 0 plus, and this is going to be 1 by x to the power n, okay. So it is nothing but what? Minus infinity by infinity form, or infinity by infinity form, minus infinity by infinity, both are okay, right? So you can apply L'Hopital, okay. So by L'Hopital, L hop लगाएंगे तो क्या हो जाएगा? We have to differentiate. So that is 1 by x. Differentiation of derivative of ln x is 1 by x, and derivative of this guy is nothing but minus n, okay, minus n upon, okay, x to the power n plus 1, right? Now if you plug 0, so it will give you 0 only, okay? So answer for this question is 0, right? So I believe this is fine, guys, and you can solve it easily. So the idea here is what? 0 by 0, 0 into infinity or infinity into 0. You can always express in terms of 0 by 0 or infinite by infinite. So this is nothing but a third type of, you can say, indeterminate forms. Now we will move to infinite minus infinite. Infinity minus infinity, right? Infinity minus infinity. Okay. So I'm just going to write here indeterminate form of indeterminate form of the type infinity minus infinity. Now there is fx minus gx, right? Fx minus gx, okay. So what is happening here is that your given limit is like limit fx minus gx. So what is happening here is your fx is going infinity, your gx is also becoming infinity as x tending to a, right? So that is the indeterminate form, right? So what we can do here is whenever fx minus gx is given, so you can write this fx minus gx as, what you can do here is you can multiply in the numerator and denominator by fx into gx. So you can write this as fx minus gx upon fx into gx times fx into gx, right? I hope this makes sense. So what you can do here is you have to just multiply in the denominator fx into gx and divide by fx into gx, okay. Now you can simplify this. Now what you can do, you can just divide, okay, and you can take the inverse, right? So at the end of the day you need this 1 by gx minus 1 by fx upon 1 by fx times gx, so which is nothing but 0 by 0 form. So again what you're doing here is you are converting infinity minus infinity as 0 by 0. Now you can apply the L'Hopital, right? So we'll solve one question and understand. Example number 3 I'm taking. So example number 3 is nothing but, suppose we have to compute limit x tending to 0, right? 1 by x square minus 1 by sine square x, right? Okay, so what we can do here is we can take the LCM first, right? So LCM we are taking here, okay? So what is this? X square sine square x, right? And which is nothing but sine square x minus x square. We can take the LCM here, right? Like this. I hope this makes sense. Hmm? Now what we have to do here is, since we have taken the LCM, now you can take out this, you can write this as, uh, you can multiply x square in the denominator and you can multiply x square in the numerator. Why we are doing that? Because there is a sine square x, okay? There is a sine square x. What we can write here is x tending to 0, x square by sine square x. We can do like write like this, and this is nothing but sine square x minus x square upon x to the power 4 only, because we are multiplying here x square by x square, right? So we can write like this. Okay. Now you know that this will be 1 directly. This is going to be 1 because there are two functions and we can apply the algebra of limit. So this limit will be applied here, this limit will be applied here, right? So you must know that limit, sine x by x tending to 0 is 1. Okay. So squaring is there, right? If you square it, still it will be 1, right? So it is nothing but limit x tending to 0, right? Sine square x minus x square by x to the power 4, right? I hope this makes sense. Now you see here what we can do here is sine square x is what? What is sine square x? Okay. And what? So you can just check here whether it is 0 by 0 form or not. I think it is 0 by 0 form. Yeah, it is 0 by 0 form. Okay. So if it is 0 by 0 form, so you can just differentiate by L hop. 0 by 0 form. Okay. Sometimes you have to make observation as well. So this is nothing but by L hop. By L hop, it is limit x tending to 0, right? Sine square, that is nothing but 2 sine x times cos x minus 2x by 4x cube. Now again check whether it is, yeah, it is 0 by 0 form. You can further differentiate this, right? So if you differentiate, because this is nothing but your sine 2x now. Okay, you should remember 2 sine theta cos theta equal to cos 2 sine 2 theta, not cos 2 theta, sine 2 theta. 2 sine theta cos theta is sine 2 theta. So limit x tending to 0, sine 2x ka differentiation is 2 cos 2x minus 2 by, and this is 12x square, right? Now you see what we can do here is, guys, is it what? 0 by 0? Is it 0 by 0? So if you plug 0, so it is nothing but 2, okay? 2 minus 2, that is 0 by 0. Yes, it is 0 by 0 form. You can further differentiate it. So अगर आप further differentiate करते हैं, right? So if you differentiate further, so that is nothing but minus 4 sine 2x upon, okay, and that is nothing but 24x. Okay, I think this is again 0 by 0 form. So limit x tending to 0 minus 8 cosine 2x upon 24. Right? So what is the answer for this question? 8 by 24, which is 1 by 3. It's a very simple question, provided you have to play with the question, right? That's it, okay? The procedure is same, so answer is going to be minus 1 by 3. Okay? So I think this is clear, and this is the perfect way of solving question. Okay? Yeah. Now I'm just going to give you one more question. एग्जाम्पल नंबर 4, ठीक है. तो एग्जाम्पल नंबर 4 says that consider a limit x tending to infinity x plus 1 by ln 1 minus 1 by x. Okay, this is a question, right? Now you have to identify which form it is, which form it is going to be. Okay. Now it's very hard, it's not that tough to identify. Okay. First is infinity and the second one is minus infinity, guys. First is infinity, second one is going to be minus infinity. Okay, please do remember, because ln 1, okay, first one is infinity, second one is going to be minus infinity. Okay, so which form it is? Infinity minus infinity form. Okay, ठीक है. So that's what you have to take care. ठीक है. So it is nothing but infinity and infinity minus infinity form. ठीक है. So this is infinity and this becomes minus infinity, right? When you will like if you plot this function, right, and check it. So I hope this makes sense. ठीक है. So what we can do here is we can apply the, again you can write this as you need to manipulate this. Okay, so what we can do here is so we have to convert into L'Hopital so that we can apply L'Hopital 0 by 0 form. So what we can do, we can take the LCM here, right? So limit x tending to infinity x ln 1 minus x, okay, plus, ठीक है, plus 1 by ln 1 minus 1 by x. So you see how powerful L'Hopital rule is, right? कि you have got any type of indeterminate forms, but still you are able to apply this infinity by infinity or 0 by 0, converting into infinity by infinity and 0 by 0, right? Okay. Now what we can do here is you need to think about it. Okay. So yeah. Now you see if you take this x, so you need to solve first this part. Okay, this part you can solve it. Okay, if you solve this part, right, if you're going to solve this part, so you will get what, because there is a process. Okay, there is a process called, like, suppose limit x tending to a fx plus gx is there, right? So you can apply the limit x tending to a fx plus, these are the algebra of limits g of x. Okay. You can write like this. In fact, this is the first. Okay. In fact, in the second also you can say, suppose limit x tending to a f of x into g of x is there. So you can write this as limit x tending to a f of x times limit x tending to a g of x. These are some theorem of limits, or you can say some okay, division में अगर दिया है limit x tending to a f of x upon g of x, so you can also write this as limit x tending to a f of x upon limit x tending to a g of x. Okay, so these are some important facts that you can remember, right? So then you can solve this question. Okay? So first of all, you have to rewrite this. Okay, so you got this now 0 by 0 form. Fine. This is nothing but 0 by 0 form. Okay. ये आपका 0 by 0 form ही है. You can check out. It is nothing but 0 by 0 form, because this has to be minus 1. If you solve this, this will be minus 1, right? How to solve this question? I mean this part. So you can check out, right? You know, this is fx, this is gx, right? Then you can take x below, okay, and then differentiate numerator and denominator. You will get minus 1. So it is nothing but 0 by 0 form, right? So if it is 0 by 0 form, then you have to differentiate, and life is very simple. Okay, so I'm not going to do this question further. You have to try. Right. So the answer for this question is going to be 1 by 2. Right. So this will be 0 by 0 form only when this part is nothing but -1. ठीक है, आप लोग करो अपने से ये question. ठीक है, I gave you the hint. Next part of the next indeterminate forms, I'm just going to solve. Indeterminate form of the type 0 to the power 0, infinity to the power 0, 1 to the power infinity, right? Okay. So now these three are very important. Okay. So guys, I'm just going to tell you some concept. Please do remember this, and then you can solve it. Okay. So structure will be what? First, you need to understand the structure. The structure is like, suppose y equal to limit x tending to a, right? X tending to a, f of x power g of x, right? This is the form of the question that they will be asking, right? F of x and g of x. Then what you can do here is, if suppose f of x is tending to 0, so some following properties are there, right? Following cases that you have to see. The first is your fx tending to 0, right? And your gx also tending to 0 as x tending to infinity, right? Sorry, as x tending to a. Next one is your fx is tending to infinity, your gx is tending to 0 as x tending to a. And third property, if your fx is going 1 and your gx is going toward infinity as x tending to a. These are the cases that you will be getting in your exam. Okay. So how to tackle these kind of problem, that is what the question is. Okay. So in this case, whenever what you have to consider is, you have to take y equal to f of x, so power g of x. Then you have to taking log both side, taking natural log both sides. You can take log ln by equal to ln f of x power g of x. Now you can use this ln equal to m to the power n, so n log m. Okay. So this can be written as gx times ln fx, right? Okay, and this is nothing but ln by. Okay, now you can apply the limit here, right? So first of all, what you have to do, this is very important to understand. Okay. Now suppose so this is what form, suppose gx is becoming 0, so ln 0 is nothing but what? Ln 0 is infinity, so 0 into infinity form, like 0 by 0 to the power 0 is nothing but 0 into infinity form, right? So you can solve this using L'Hopital. Again, you can convert this into L'Hopital, right? 0 into infinity form का मतलब क्या है? You can convert, you can solve this part first, and you will get, let's say you're going to get some limit, right? So see, ln by limit x tending to a, limit x tending to a g of x ln f of x, right? So what you can do here is, you can write this as ln limit x tending to a by, okay, so you take this ln outside, you can apply the limit inside the limit, okay, inside this ln. So this is, and let's say if you are computing this part, so this is nothing but 0 by 0 into infinity, so you got some L. Now what is limit, guys? Limit x tending to a by, so this ln will go this side, so it is nothing but e raised to power L. So this is the answer. ठीक है. So I think this is clear कैसे करना है. It's a very simple process. You have to take the limit both side and then, sorry, you have to take log both side and then. So if we have got some moving function, right? If we have got some kind of moving function, you can say, let me take the example here. So I think it is example number 5. I am not sure कौन सा number है. So suppose you have to compute limit x tending to 0 plus x to the power x. Okay, so this is nothing but a moving function kind of thing. Now you have to find the limit here, right? So you don't know how to find the limit for this because 0 to the power 0, it is nothing but 0 to the power 0 form, right? So what we can do, we can take log both side. ठीक है. So यहाँ पर let कर सकते हैं by equal to x to the power x. So this is nothing but ln x ln x, right? Now we have already done x ln x, right? What is x ln x? That is nothing but 0, right? You can solve this part. Okay, now apply the limit. So limit, ln you can take out. So ln 0 plus by, which is nothing but limit x tending to 0 plus x ln x. Okay, and this part we can solve it. Okay, so how to solve this? You can say that limit x tending to 0 plus ln x you can keep up, right, by 1 by x. तो इसको हम सॉल्व करेंगे तो क्या आएगा? ln x 0 plus, it is 1 by x upon minus 1 by x square, which is 0 only. So your answer for this by equal to e raised to power 0, which is by equal to 1. So answer is 1 for this question, right? Okay, so do remember this, कैसे सॉल्व कर रहे हैं. ठीक है, ये आपका क्या है? 0 into infinity फॉर्म है. Now we are converting into what? Infinity by infinity form and applying the L'Hopital by L'Hop. खत्म. ठीक है. Can we take one more question? So example number 6, let us take. So limit x tending to 0 plus cosine x to the power 1 by x, right? Now you see what form is this? So 1 to the power infinity form. This is 1 to the power infinity form. Again you have to apply the same logic. So let's say by equal to cosine x to the power 1 by x. Now you can say ln by equal to 1 by x ln cosine x, right? ln cosine x, fine. So yeah, now what we can do here is we can apply the limit x tending to 0 plus ln by equal to limit x tending to 0 plus 1 by x ln cos x. ओके, सो इससे इजी कोई नहीं बताने वाला, याद रखना. ठीक है, जो मैं आपको बता रहा हूं इससे इजी कोई नहीं बताने वाला है. ठीक है, तो आपको प्रैक्टिस ऐसे ही करना है. थोड़ा सा तो माइंड लगाना ही पड़ेगा इफ वी वांट टू गेट अ गुड रैंक. ओके, सो दिस इज नथिंग बट नाउ वी हैव टू सॉल्व दिस पार्ट. ओके, जस्ट फोकस ऑन दिस राइट हैंड साइड, फॉरगेट अबाउट दिस, राइट? ये तो इजी है, बस यू हैव टू टेक बाय, यू हैव टू फाइंड बाय, राइट? तो फोकस ऑन दिस पार्ट. तो ये कितना हो जाएगा? लिमिट एक्सटेंडिंग टू 0 प्लस ln cos x by x. It is nothing but what? It is nothing but cos 0 is 1, so it is nothing but 0 by 0 form. So differentiate कर सकते हैं by L'Hop. L'Hop करेंगे तो क्या आएगा? x 0 plus, right? So ln cos x, so 1 by cos x times minus sin x upon 1 only, right? Yeah, ठीक है, 1. So what is this, guys? 0 plus if you plug, and this is nothing but tan 0. Tan 0 is 0, right? I mean, if you plug 0 here, it is 0 only. So ln limit x tending to 0 plus by, तो यहाँ से बाई कितना आ गया लिमिट e रेज़ टू पावर 0 विच इज 1, इसका भी आंसर 1 आ रहा है, ठीक है। ओके, नाउ लेट अस टेक वन मोर क्वेश्चन। सो आई थिंक प्रोसीजर इज क्लियर, जो प्रोसीजर मैं बताना चाहता हूँ क्लियर रहना चाहिए, राइट। सो लिमिट, सपोज यू हैव टू डू लिमिट x टेंडिंग टू 0 प्लस, question is given, that is 1 by sin x 1 by x, right? So now if you put 0, so it is nothing but what, infinity power, and this is nothing but 1 by 0, which is infinity to the power infinity form. Again it is indeterminate, so again you have to take what, by equal to 1 by sin x, जो भी exponent form में your indeterminates are there, so always take this, take ln by 1 by x ln 1 by sin x, right? Now you have to solve this, okay? It's a very simple procedure, ठीक है। Sorry, I believe there was ln x, this was ln x, ठीक है, तो ये ln x है, this is ln x only, right? Now again you can apply the, this is so limit by x tending to 0 plus ln by equal to limit x tending to 0 plus 1 by ln x times ln 1 by sin x. Okay, now you have to solve this because in the numerator it is ln 1 by sin x, so you can differentiate, you can apply L'Hopital. Okay, so if you solve this part, please solve this, okay, इसको आपको solve करना पड़ेगा, apply the L'Hopital, I mean, okay, in the numerator, and okay, by L'Hop here, by L'Hop, so you will get -1, so your by limit x tending to 0 plus e raised to power -1, which is 1 by e. So this question is important guys, they might ask in numerical answer type, मैं बार बार नहीं बताऊंगा, आप खुद से करो, ठीक है। ln 1 by sin x is in the numerator, ln x in the denominator, इसको आप कैसे लिखोगे, ln 1 by sin x in the numerator upon ln x in the denominator. Now it is nothing but 0 1 by 0, right, infinity, okay, so you can do it, right? Fine, so I believe this is fine for all, and this is all about all the parts that I have covered, right? So jitne bhi indeterminate forms hain, you can do that, okay, sare indeterminate forms I have discussed, okay? So I think now you will be able to solve, and in every single indeterminate forms there is a L'Hopital rule we are applying, okay, to get the answer, okay? So please work on differentiation, how to differentiate a function, how to, that is very important, otherwise limit questions, I mean, can become difficult as well. Yeah, so once I will cover application of derivatives, so you will be having new perspective, right, to solve the limit questions. और मैं कुछ shortcuts भी आपको बताने वाला हूँ कि like how to directly find out the limit. Okay, so be ready for everything, ठीक है? So I think this is clear, and yeah, ठीक है. So this is over for you, and basically one more concept that I want to highlight here is, guys, rate of the growth of the function if you want to find, right, rate of growth of the function. So we always use limit concept, okay. Rate of growth of the function if we want to find, so we always use limit concept, okay. That is what I found out while teaching the limit, while teaching the indeterminate forms. क्योंकि आपके data structure algorithm में whenever we compute time complexity, like for gate data science people, I am telling this. So like you need to see, suppose you have got 5 functions, right, and you have to tell which function is faster, which function is slower, like the rate of growth of the function is faster or slower, right? So there is a way, right? There is a way to find out. Okay. uh, okay, yes. So I always try to find some concepts which are very important, okay, and you must know that. So what I'm trying to say here is, suppose you have got some sort of function, मतलब लास्ट सेशन में मैंने आई थिंक बताया था आपको कि लिमिट 1 मिनट, लेट मी चेक आउट, ठीक है, रेट ऑफ ग्रोथ ऑफ द फंक्शन, yes, rate of the growth of the function, fine. So suppose you have got the first type of, okay, rate of growth of function. If we want to find the function, right? Suppose you have so we can use L'Hopital rule, right? Or we can use this limit concept. So x tending to infinity, suppose fx upon gx is there. If fx upon gx is there, and if this is tending to, you can say, plus infinity, if this, when we are computing this limit, okay, and it is becoming infinity plus infinity, so what we can say here is that, guys, we can say that the numerator is becoming more faster, okay, right? So you can say that your fx is greater than g of x, okay. So in this manner you can say that fx is faster than g of x, okay. I hope this makes sense. And suppose limit x tending to infinity, g of x upon f of x is there, okay, and it is becoming 0, right? So which one is rate of growth, like which one is slower, like that also you can determine, okay. So this is one concept that you can use. And last time I told you there are some functions we can say that we have got the function like ln x, okay, which is slower than, okay, which is far slower. This is faster than ln x, right? And then you can say that x to the power 10, right, e raised to power ax, but a must be greater than 0 here. So this guy is very fast, rate of growth is very fast. This guy is slower among all, slowest, okay. So fine, so we will meet in the next session, right, and we will discover some more concepts. So you can expect ki next session में application of derivative first of all I will discuss. Derivatives, and again I will come back to limit, okay, like I have to talk about existence of limit, okay, though you know everything, okay, but I will talk about graphical approach ही बताएंगे, लेकिन सबसे पहले हम कवर करेंगे एप्लीकेशन ऑफ लिमिट, क्योंकि गेट में जो जहां से क्वेश्चन आते हैं वी हैव टू डिस्कस दैट ग्राफिकली, वी विल ट्राई टू कंप्यूट लिमिट, ठीक है, एंड some shortcuts, right, after learning this, and then we will discuss you can say some shortcuts, okay, understand. And application of derivative is the last topic, you can say, for single variable calculus, but I have to cover also integral part, right? So we'll meet in the next session. Thank you.